You've probably seen those videos, right? Those jaw-dropping time lapses of entire buildings just appearing out of nowhere, almost overnight. A hotel built in a weekend, an apartment building in just over a day. It feels like something out of a sci-fi movie, but believe it or not, it's real. And it's all powered by a technology that's probably not what you think. So let's just get right to it. That headline, is it for real? Can you actually truly build a 10-story building in 28 hours? I mean, is that just some kind of marketing gimmick, a trick of the camera? Or has construction really taken such a massive leap forward that we could reshape our cities in a matter of days? Well, the answer, believe it or not, is a resounding yes. What you're looking at is the Garden A1 building, and it went from a flat foundation to a fully stacked 11-story structure in less than 29 hours. It's absolutely wild. But the real story here isn't just about the speed. It's about how on earth this is even possible. And the answer is probably going to surprise you. So, to really wrap our heads around this, we've got to start with the company that's making all these headlines. We need to get a sense of just how big and how fast these projects really are. Okay, so there's a Chinese company called the Broad Group, and they're the pioneers behind this, and their track record is just stunning. I mean, look at this. They've put up hospitals in 48 hours, a massive 57-story skyscraper in only 19 days. And more recently, a 26-story tower in just 5 days. These are not small sheds we're talking about. These are incredible feats of engineering that are totally changing the game. When you see that kind of speed, your mind probably jumps to one thing, right? 3D printing. It just makes sense. It's futuristic, it's automated, you can just print a building, layer by layer. Well, that's where the story takes an interesting turn. Let's just pause here for a second and bust a very, very common myth. The idea of a giant printer just squeezing out a perfect move-in-ready house in a day, it's a cool idea, but it's not what's actually happening. You see headlines like this all the time. They paint this incredible picture, right? Like we found a revolutionary solution to the housing crisis. Just press print and 24 hours later, a new home appears. But this story, it's missing some really important fine print. So here's the truth. As publications like Fabulous have pointed out, those giant 3D printers, they don't print homes. They print concrete walls. And that's a really important distinction. They extrude the basic shell of a building, but let's be honest, a shell is not a home. So that whole 24-hour print time, it leaves out, well, pretty much everything that makes a house a house. You still need to put on a roof, install windows and doors. You still need plumbers, electricians, and HVAC system. And you still have to do all the flooring and interior finishing. Oh, and the concrete itself, it needs days to cure and strengthen before you can even think about starting that work. That 24-hour print is just one tiny step in a much, much longer process. Okay, so that brings us back to our 29-hour apartment building. If it wasn't 3D printed, then what is the secret sauce? What is the real game changer that's making this happen? The answer isn't about printing on-site at all. It's about building off-site. The real revolution here is a process called modular construction. The best way to think about it is it's less like traditional construction and more like manufacturing a car on an assembly line. So instead of building everything from the ground up out in the rain and mud, you manufacture entire sections of a building. We're talking entire rooms or apartments in a controlled factory environment. These finished modules are then just shipped to the site and put together. And here's the real secret to its incredible speed. It's a two-track approach. While one team is at the construction site pouring the foundation, a totally separate team is in a factory, maybe hundreds of miles away, actually building the apartment units. Then, once the foundation is ready, the finished modules just show up on trucks, ready to be stacked together like high-tech Lego blocks. There's no on-site welding, it's just pick, place, stack, and bolt. And you can see the whole process right here. On the left, that's a completely finished module, built just right so it can fit on a standard truck. And on the right, you see that exact same module being craned into its final spot. It's really more of a logistics puzzle than a construction project at that point. And the amount of work they do in the factory is just astonishing. Think about this number for a second. 95%. That's how much of the building can be finished before it ever even gets to the site. We're talking plumbing, electrical, even the paint on the walls. The on-site work isn't really construction anymore. It's assembly. So, you're probably wondering, if this method is so revolutionary, why aren't all our buildings made this way? Well, it turns out that while the benefits are massive, the challenges, especially when you want to build really tall buildings, are just as significant. First, let's look at the advantages, because the data is really compelling. You can cut construction time by up to half. You can reduce the total project cost by as much as 20%. And this one is huge for the environment. You can slash on-site construction waste by up to 90%. Building in a factory is just way cleaner and more efficient. But it's not as simple as just snapping blocks together. There are complex decisions to make. The choice of material, for example, is a huge one. Steel modules, which is what the broad group uses, are a lot lighter and can be bolted together really fast. But concrete modules give you much better fire resistance and sound insulation. It's a classic engineering trade-off between speed, weight, and performance. The really big hurdles start to pop up when you want to build tall. How do you connect all these boxes together so they can handle strong winds and earthquakes? How do you make sure the whole building is stable? Right now, there's a real lack of official design codes and building guidelines, which makes a lot of engineers and city officials pretty cautious. And this right here gets to one of the biggest safety questions. What happens if a critical module on a lower floor gets damaged? Maybe in an explosion or a car crash. In a normal building, the weight is spread out. But in a modular tower, engineers have to prove that losing one block won't cause a catastrophic chain reaction. Solving this structural robustness problem is really the key to building taller and safer with this method. So where does all of this leave us? Is the future of our cities really going to be assembled in a factory and then just delivered on the back of a truck? The big takeaway here is actually pretty simple, but it's also profound. The revolution we're seeing isn't the 3D printers sitting on a muddy construction site, it's the clean, efficient factory. The real innovation isn't just a new tool, it's a complete paradigm shift in where and how we build our world. And that brings us to the final, really critical question. With housing shortages and affordability crises in cities all around the globe, we desperately need faster, cheaper, and more sustainable ways to build. Modular construction seems to offer a really compelling answer. So is the future of our homes and cities one that will be manufactured, delivered, and assembled? It's a future that might just be stacking up right before our very eyes.